Okay, good evening, ladies and gentlemen. My name is Fatima Vanessa, and I would like to present my research entitled Investment Feasibility and Risk Analysis of Biogas Power Plant from Palm Oil Mill Effluent. In this research, my co-author is Dr. Andi Nur Saman Someng, and we are from Chemical Engineering Department, Universitas Indonesia. Here is the overview content of my presentation today. And let me begin my presentation with introduction. Energy is a basic need that is vital for human life. The need for energy continues to increase, so the availability of non-renewable energy is continued to decrease. On global scale, 84% of total energy use comes from fossil fuels, which crude oil, gas, and coal dominate. Meanwhile, in Indonesia, energy utilization still depends on crude oil, which is 49.5% of the total energy mix in national scale. Considering Indonesia is one of the largest palm oil producers in the world that can fulfill 90% of global palm oil demand, with more than 600 palm oil plants, biogas power plant that utilizes palm oil mill effluent has great potential to further develop. From more than 600 palm oil plants, only 25 plants produce biogas and less than 10 plants use biogas as fuel for biogas power plant. So the utilization of renewable energy such as biogas from palm oil mill effluent can be a solution to the existing problems. Next, methodology. This research is conducted in several steps. Starts by making technology schemes that will be simulated using SuperPro Designer software to calculate the amount of biogas produced and electricity generated. And then the results is used to calculate the project's economic parameters for the investment feasibility analysis. After comparing the economic aspects of the project and obtaining the best scheme, a sensitivity analysis is conducted, and a risk analysis of the project scheme are carried out using hazard identification methods and bow-tie diagram methods. In this research, there are 6 technology schemes based on combination of technology that commonly used in processing palm oil mill effluent to biogas, which are covered lagoon and continuous stirred tank reactor or CSTR. And the technology for the biogas power plant, which are open cycle gas turbine, combined cycle gas turbine single shaft, and combined cycle gas turbine multi-shaft. As I mentioned before, there are 2 common technology that can be used to process the palm oil mill effluent to produce biogas, which are CSTR and covered lagoon. Both of technologies are anaerobic digestion that have 4 main steps, which are hydrolysis, and the second step is acidogenesis, and then acetogenesis and methanogenesis. For the biogas power plant technologies, there are 3 common technologies that can be used. The first one is open cycle gas turbine that has 3 main equipment: compressor and burner, gas turbine, and electrical generator. And then combined cycle gas turbine. Combined cycle gas turbine has 2 configurations, single shaft and multi-shaft. Combined cycle gas turbine single shaft have only one generator that connected to both gas turbine and steam turbine. Meanwhile, the multi-shaft has 2 generators that each turbine is connected with different generator. For the simulation process, biogas production, which then used as fuel on the biogas power plant, is simulated using SuperPro Designer project, starting with pre-treatment of the palm oil mill effluent with feed flow rate of 240 14,000 kilograms per day. The pre-treatment process begins with filtering palm oil mill effluent, and then the outlet stream is cooled using condenser, so then the clean palm oil mill effluent can match the biodigester operating conditions. The next step is mixing palm oil mill effluent flow with the wastewater from the biodigester in order to increase the conversion of the biogas formation. After that, the mixed flow is fed into the biodigester, and then the biogas is produced. On the scheme 1, 2, and 3, the scheme using covered lagoon technology as the biodigester, and scheme 4, 5, and 6 are using CSTR technology as the biodigester. In this simulation, it's assumed that there is no excess biogas that needs to be burned using flare. After that, the biogas produced is not directly transferred to the generator because it needs to be purified first on the post-treatment process. After the post-treatment process, the biogas is ready to be the fuel of the biogas power plant to generate electricity. This is the economic parameters that used in investment feasibility analysis. And then for the results and analysis, the biogas produced from scheme 1, 2, and 3 using covered lagoon technology is shown at the table, and biogas produced from the scheme 4, 5, and 6 is also shown on the table. As we can see, the scheme 6 have the most biogas produced and electricity generated. On the investment feasibility calculation, the calculation is based on the economic parameters that referring on the economics parameter on table 2. As we can see in the table, the scheme 1 and 2 have NPV and profitability index below zero, which is the investment is not feasible. For the scheme 4, the NPV is positive, but the profitability index is less than 1, which means the investment is also not feasible. For the scheme 3, 5, and 6, the investment is feasible and generate profit. So, from the investment feasibility analysis, there are 3 feasible schemes and 3 non-feasible schemes in this research. For the 3 feasible schemes, we compare the NPV, payback period, and ERR value. So we can conclude that scheme 6 is the best scheme, that is combination technology between CSTR technology and open cycle gas turbine multi-shaft. This is the picture of the simulation. And then sensitivity analysis is conducted by decreasing and increasing the cost of capital investment parameters, electricity selling price, and utility cost by 5%, 10%, and 15% to see changes in the value of ERR, NPV, payback period, and LCOE scheme of scheme 6. As we can see from the graphic, sensitivity analysis of the parameters that can affect investment in the biogas power plant with scheme 6 shows that the selling price of the electricity is the parameter that most influences the net present value or NPV, ERR, payback period, and LCOE values of the projects. In this research, risk analysis is conducted using hazard identification method and bow tie diagram. The hazard identification analysis of biogas power plant project resulted a list of risks that need to be prioritized to be handled. Specifically, risks that are high risk category as can be seen in the following table. In the hazard ranking based on hazard index, CSTR is there are 5 high risk hazards, 9 moderate risk hazards, and 6 low risk hazards. After ranking the hazards that have high value index are further analyzed using bow-tie diagram method. Based on the hazard index ranking, CSTR has highest hazard index. So if the CSTR is failed, it can result great losses compared to the other equipments with hazard value, with high hazard value. In this bow-tie analysis, CSTR is the equipment that contributes significantly in the top event, that is biogas leakage from CSTR. The hazard on this top event is biogas that's flammable and toxic. The bow-tie diagram is shown in the figure. So the conclusion is the result of investment feasibility analysis of the biogas power plant project that utilize palm oil mill effluent are 3 technology schemes of the project are feasible to invest in, and there are 3 technology schemes that are not feasible, with scheme 6 with being the best scheme. Sensitivity analysis of parameters that can affect investment in scheme 6 is electricity selling price. The hazard identification studies identified that there are 5 high-risk hazards, 9 medium-risk hazards, and 6 low-risk hazards on scheme 6. And the risk analysis using bow-tie diagram identified biogas as a hazard led to the top event in the form of leakage of biogas from the CSTR. The top event has 6 threads with a total of 16 preventive controls, as we can see in the left side of the diagram. And on the right side of the diagram, there are 6 consequences that will occur with a total of 17 mitigation controls. Thank you for your attention.
Thank you very much for your presentation. I would like the audience, if they have any question for you. How about the environmental impact of this biogas of the palm oil?
Yeah. For the environmental impact, I did not conducted the research. So I'm sorry, the palm oil mill effluent is containing methane gas, which is a high contributor to the pollution. So if the methane gas is not treated, it can be major pollution to the environment.
Okay, thank you very much. Thanks for your presentation.
Thank you.